big conference there, and Professor Ponusami invited me to went there to participate to that conference.
Okay, sir. Okay, sir. Okay, sir.
It's very nice, sir.
Yeah.
We are very happy to meet you, sir.
me too, because I was many times in India, and for me it's a pleasure also to participate live. They are not on the Zoom or internet. I like very much.
It is a wonderful opportunity for us, for our
Yeah.
students also.
Yes, sir.
Thank you, and for me also, yes, to have contact with people from India.
Okay,
Yeah.
sir. 1 second, sir. 1 second, sir. 1 second.
And we are live streaming this session in YouTube, sir.
Please.
Sorry, sir. Sorry.
This
Sorry.
session is live streamed in YouTube also, sir.
Yeah.
YouTube.
I will try to do my best.
You're always best, sir. You need not try.
Yeah.
Kavita
So
told
much of
me everything,
experience.
sir, about you.
And
Now
Kavita told me about you, sir.
my head of the department is saying that I told many good things about you to her.
Thank you very much. Thank you very much. And your college is only for women education?
Yes, sir.
Yes,
Yes,
sir.
yes, yes.
Yeah. Yes,
It
and
was started long ago. More than 50 years of service experience is there, sir, and it was started long ago to promote women education. Yeah, even at that time it was very women were not very restricted at home itself. They were not allowed to even come out of the home for education. So at that time our founders started this institution. So comparing to your university, we are very little what to say, and we are very we have the privilege of having you here, sir, and looking forward to more and more collaboration with you to bring up our students also to your level in the future, sir.
thank you. For me, it's a pleasure to cooperate with your institution. Yeah. And now the audience, maybe it's 9 now.
They'll be just joining, sir. Soon they'll
Yes,
join our students.
Yes, I should wait a little bit.
We shall wait for a little while.
Yeah, yes. In my country, from just this week will be 1 year when we started the online education because of coronavirus disease. And 1 year ago, we started these Zoom lectures with our students, Zoom lectures, Zoom exams, and so on. Yes, we don't have face-to-face meeting with students. Yes, fortunately, I and my wife, we already have vaccinated against coronavirus.
Oh, that's nice, sir.
Yeah.
No, வரல participants வரல நிறைய.
Kavita, some network issue. I think principal will try to come here.
Principal ma'am வந்துட்டாங்க மேம் உள்ள.
Yes, yes. Good morning. Good morning.
Ma'am, good morning, ma'am.
Good morning.
Yes.
And during this period, you also have the lectures online, or you have live lectures?
We had online lectures only, sir. But now, in the recent past, we have started our practicals and lab sessions in the college.
Yeah, yes, I understand.
Here, the people above 60 are now getting vaccinated, and according to the ages, they are vaccinating the citizens, sir. So step by step process. And ours is a very hugely populated country comparing to yours. So it will take time to completely vaccinate everybody.
Yeah. Yes. In my country, maybe almost all of the universities have lectures only online. Because we try to eliminate this coronavirus. So people, maybe 1/3 from my country are vaccinated.
Okay.
Yes. All are closed: restaurants, the theaters, movies. Big stores are closed, and during the night there are circulation restrictions. Yes, because it's a very serious illness in all Europe, you know, this coronavirus.
Yes, sir. Yes.
Kavita, shall we start? Pratibha is there? No.
Yes,
Pratibha? Yeah.
am I audible,
ma'am? Yes, ma'am. Yes.
Okay, shall we start, ma'am?
Yes, ma'am. Kavita, is it okay?
Yes, ma'am.
Okay. Yeah, start.
The best preparation for tomorrow is doing your best today, and today is going to be a great day. I'm Pratibha, PG Association Secretary, Department of Mathematics. It takes me immense pleasure to extend a gracious welcome and great noon to everyone present here. For SKNB Vaishnav College for Women, Department of Mathematics, self-financially present, international webinar on mathematical analysis and recent trends in career opportunities. Prayer brings victory. Let us begin the session by rendering the prayer song. So let's begin the prayer. I request our department choir girls to sing a prayer song.
So may I start my
just a minute, sir. Formalities are going on. Just a minute, sir. We'll start with a prayer.
परं त्रिसत्यं सत्यस्य योन्यं निहितं च सत्ये सत्यस्य सत्यं हृदसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने शरणौ कथाय त्रष्टौष्टकर्मसु मनस्तवपादयो नमः स्मृत्यां शिरस्तव निवासजगत्प्रणामे दृष्टिसतां दर्शनेस्तु भवस्तनूनां नमो भगवते तस्मै कृष्णाय भुजगर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Thank you.
Thank you, girls. As well-known saying, the beginning is the most important part of the work. I'll request our principal, ma'am, Dr. R. Geeta, to begin this event with an inaugural address. Welcome you, ma'am.
Right. Good afternoon to all of you who are here, and a special welcome to our resource person, Dr. Theodor Bulbaca, Faculty of Mathematics and Computer Science from Romania, who is here to address our faculty and students. We are really very happy and excited to have you with us. To give a brief about our college, so our college was started in 1968, and we offer 15 UG programs in the aided stream. and 30 UG and 15 PG programs in the self-support stream, and research programs leading to PhD in 10 disciplines. So the student strength is 6,500 plus, and I have got 280 wonderful faculty who impart quality education to all our students. As far as the Department of Mathematics is concerned, we offer a UG program in mathematics and a PG program in applicable mathematics, which has got a lot of students getting into it because it is a blend of both mathematics and computer science. And you are the right person to address all our students also today, you being from both mathematics and computer science faculty. Sir, the focus on the curriculum of these department is mainly algebra, mechanics, then differential and integral calculus. They have trigonometry, operations research, and C programming also. So to bring out the skills in problem solving and to hone the skills of students in their approach to mathematical problem solving, the college has started or initiated Sparkles, which is a compilation of articles written by the students. So it is a research compilation of this one, and we are about to release the first volume sometime during March. Sir, we are really thankful to you because this is a right moment where you are here to address about the fundamentals of algebra, and the way in which you are going to present, I am sure students would have a love in approaching these theorems and see how they can use mathematics to the best extent to solve certain problems also. And it is a wonderful opportunity for all our students because we haven't heard from resource persons of such a caliber, because I just went through your biodata, and a lot of that is, we couldn't leave our eyes looking into your profile also. So being a member of editorial board, a lot of paper publications and a lot of things, I'm really very, very thankful for the department to have arranged you. The main point is that an exposure to our students from persons like of your caliber is really going to give a lot of confidence amongst them to move forward also. So with all wonderful memories of your whatever you are going to say today, and I welcome you to be with us, and we would love to hear from you about how to approach this problem solving, that is the fundamental theorem in algebra, using simple 3 different methods. Thank you, sir, for being with us, and once again I welcome you for to our webinar today. Thank you so much.
Thank you also.
Thank you so much, ma'am. Now, I request Dr. Sudha Sendal, ma'am, Head of the Department, MSc Applicable Mathematics, to welcome our guest, Professor Dr. Theodor Bulboca, Faculty of Mathematics and Computer Science, Babes, Bologna University, Romania. Welcome you, ma'am.
Good afternoon to everyone. Mathematics is the most beautiful and most powerful creation of the human spirit, Stephen Bannock. It is my pleasure to welcome our chief guest, Dr. Theodor Bulboca, Faculty of Mathematics and Computer Science, Babes, Bologna University, Romania. He has published many papers in national and international level. He has published 7 books and monographs. He is a member in Scientific Technical Program or Advisory Committees of International Conferences, the editorial board member or referee for journals included in international databases, and also a referee for many Romanian journals. He has been a resource person, invited speaker in many conferences, seminar and webinar. Once again, I welcome and I warmly and respectfully welcome our chief guest, Dr. Theodor Bulboca. Welcome you, sir, please.
Good morning. Here it's 9 a.m. In Romania, and I would like to thank for the nice words you said about me. I would like, may I share screen now, because I cannot access. Do you want to allow me to share screen to put?
Yes, sir, you can share, sir.
You can share, sir. You can share.
No, I am host disabled participants screen sharing. I'm not.
Yes. See, you have to enable him. You have to enable that option for sir.
I need the permission of
Permission from the host.
administrator of because you started this session, and I am a host here, and I am not allowed.
Yes, sir. Once again, Kavita, you make him co-host.
He's in the panel, ma'am. He can share the screen.
Yes, I cannot share.
Okay, just a minute, sir. Ma'am, our screen share பண்ண வரலங்கறாரு. Screen share பண்ண வரலங்கறாரு. அவருக்கு சார்க்கு.
1 second, sir.
Sir, because you're one of the, since you're one of the panelists, you could share the screen, sir. Can you please try one more time?
Yes, now it's possible.
Okay.
Thank you.
Okay,
Thank
sir.
you. Now it's possible. I would like to say some words about my university. My university was founded in 1581 as a theological university. So it's an old university. And it's the #1 university of Romania. We have a very good performance in mathematics. United States world news and reports a few years ago placed our faculty of mathematics on the position number 62 in the world, according United States world news and reports. Our university has approximately 40,000 students. I don't know, maybe 27 faculties, maybe 27 faculties. And what is important that our university is the #1 ranked in Romania. So it's a university with a good tradition. Also, I would like to emphasize that I was many times in India. First time I was in 90 just in Chennai, with the occasion of the 60th anniversary of Professor Padmanabhan. I know that he's passed away a few years ago. But I remember that last time I was in south of India, in Viluppuram. I was to a conference in maybe in 2014. Yes. Let's start with my lecture now. Dr. Kavita, did you see this screen with my beamer?
Yes, sir.
Yeah.
It's
okay.
clear.
Okay. When I was a university student, and not only to my university, also to many other universities, students didn't show proof of fundamental theorem of algebra. Even to algebra, they didn't learn this the proof of this theorem. So when I was a university student, I check on my library, which is a very good one, and I found only a proof given in 48 by Arnold, which use elementary methods for the proof of fundamental theorem of algebra. But this proof was very complicated, very bulky. I would like to show now during in 1 hour three proof of this theorem. The second part, I will skip the second part of this presentation because it takes too long time. There I want to present this Casorati-Weierstrass theorem, which represents the weak Picard theorem, but it could be proved very easy. So I will present only this first part, the fundamental theorem of algebra, with first, second, and third proof. And this part, I believe that could be understood by also by students, but I am very sure that also it's helpful for mathematicians. What about this? The theorem of the fundamental theorem of algebra. It's a very known result that said that any complex polynomial, that means coefficients are complex, p of z of this form, this with a sub n not zero, that means the degree of this polynomial is n. Of course, n, it's in n star, that n star means natural numbers from starting from 1, 2, so the degree of polynomial is at least 1. This polynomial has at least one root in C. Okay, if this polynomial has z1 root, we could divide the polynomial by z minus z1, and the remainder will be a polynomial of degree z minus 1, and we could do this n times. Yes. So as a conclusion, this polynomial has n roots. Of course, not necessary different roots. Okay. Let's give the first proof. The first proof is a very elementary one. It's not very easy, but this proof need only to know Cauchy integral theorems. Yes, so it doesn't need other high-level complex analysis knowledges. The first step, I said, on my opinion, it's very important. In the first step, I will prove that it is sufficient to prove that the above result, that means this result, it is sufficient to prove the above result only for those polynomials which take real values whenever the argument is real. Let's prove this fact, because it's sufficient only to prove this. If P is an arbitrary polynomial, let's define by P bar the polynomial built in this way. All coefficients, not the argument, all coefficients are conjugate. Yes. Then if we denote by Q the product between P and P bar, what means? When Z is real, P bar Z It's the conjugate of pz. So this q polynomial, when the value of q in this z real points will be real, this polynomial q. So this polynomial q will have real values whenever the arguments are real. Okay, suppose that z naught it's a root for q. That means p at z naught times p bar at z naught, it's 0, which implies that z naught is a root for p or for p bar. If it's a root for p, it's okay. If it's a root for p bar, for this polynomial, then pz naught is p bar z naught conjugate, because conjugate of conjugate gives the polynomial p. So if p bar z naught is 0, the conjugate is 0, so z naught, its z naught bar will be a root of p polynomial. Then it follows that the polynomial p has at least one root. Okay, so if q has one root, then p will have one root. Because this product should be 0, that means the first case p in z naught will be 0, or the other case that follows, p in z naught bar will be 0. This is a very important step. Then suppose that we have such polynomial that takes real values whenever the argument is real. And suppose that the conclusion the conclusion of fundamental theorem of algebra is not true. So suppose that p z naught is not 0 for all z in C. That means p of x is not 0 for all x real. But we know that p takes real value whenever the variable is real. P it's a continuous function because it's a polynomial, and if a continuous function doesn't vanishes on a set on R, then P has the same sign and the sign of P and the sign of 1 over P will be the same. So the P on the all real axis will be positive or will be negative. Only one of these two variants holds. So, and this will be true also for 1 over P. What's happened in this case? In this case, I wrote that there exists this integral, and this integral doesn't vanishes. Let's explain. This integral is an integral where the integration variable is theta. When theta runs from minus pi to pi, 2 times cosinus theta run from minus 2 till 2. But the function p has the same sign on the whole real axis, so the sign of p on the interval minus 2, 2 will be the same, positive or negative, because it's a continuous function and has a constant sign, positive or negative. The integral will be strictly positive or strictly negative, but the integral will not be 0. Okay, let's remember this result. Integral will not be 0. If we denote by z e to I theta, when theta run on the all interval minus pi, then z runs over the all unit circle from minus pi to pi in the all unit circles. So if we denote by gamma this function, gamma of theta e to the I theta, when theta run from this interval, then the path of theta will be the whole unit circle. And for simplicity, we denote this unit circle with positive orientation, because theta runs from minus pi to pi. Will denote this circle with modulo of z equal 1. Okay, what we can see, z times z bar will be e to the minus I theta, z times z bar will be 1, z will e to the I theta is cosinus theta plus I sinus theta, and z plus z bar will be 2 times cosinus theta. So instead of 2 cosinus theta, we'll write this z plus z bar, but z bar is 1 over z. Z bar is 1 over z. So 2 times cosinus theta will be z plus 1 over z. So instead of 2 cosinus theta, we will write this z plus 1 over z. Who is the d theta, differential of theta? Theta is the integration variable. If we differentiate this equality, dz will be this very simple I e to I theta d theta. So this will be z e to I theta. So this z will be I z d theta. So d theta is dz over iz. I from denominator is minus I. Okay, and if we replace these values in integral 1, 1, we will obtain that this integral will have this form. Integral on the path gamma on the whole unit circle, p here it was cosinus theta, and dz times minus 1 over z is d theta. So it's all. Let's compute the proof is very simple. Let's compute this nominator. This nominator. P z plus 1 over z. We replace z with this one. We compute all these powers, sorry. We will compute all these powers, z plus 1 over z to the second, to the third, to the fourth, to the n, by using Newton binomial expansion formula. And we will see that that this sum will have this form, because here from the last term, when we will expand by using Newton binomial formula, the nominator will be z to the n, and the nominator q of z will be a polynomial. This polynomial will have this polynomial have q of 0. Let's see the last term. The last term will be z squared plus 1 over z to the n, and the free term will be a sub n. A sub n will be not 0. So this polynomial will be an nth degree polynomial. Okay. If this polynomial, this also is a very important part, if this polynomial vanishes in z0, it's not allowed to be 0 because here appear to the denominator, then also here appear to the denominator. So z0 is not allowed to be 0. That means if q of z0 is 0, that means the left-hand side, p z0 plus 1 over z0 will be 0. And what means this? This is a contradiction with the fact, because I'm going back, we suppose that p has no any complex root. So here we obtain that p has a complex root, this one. So this assumption that the function q, which appear here, has a root, give us a contradiction. So this function q cannot be 0 for all z in C. This function q cannot be 0 for all z in C. If this function doesn't vanishes and it's a polynomial, 1 over q will be holomorphic because q doesn't vanishes and q is a polynomial. So q is holomorphic, 1 over q will be holomorphic. I explained here because q is holomorphic and q not vanishes in C. So 1 over q will be holomorphic in C. 1 over q is holomorphic in C. If we multiplied with z to the n minus 1, this function will be holomorphic in C. Yes. If we replace this pz plus 1 over z with this one, we obtain this integral. Yes, we obtain this integral. This function z to the n minus 1 over q, it's holomorphic. So according to the Cauchy integral theorem, this integral will be 0. Okay, this integral will be 0, but we already obtained because of 1, 1 that this integral is not 0. So we get a contradiction. We get a contradiction. Thus, this proof, it's a very simple one because the proof we use only the fundamental, only the Cauchy integral theorem, only the Cauchy integral theorem that shows that in a closed rectifiable path, the integral from a holomorphic function is 0. Yes. This is a very simple proof. It's simple from the point of view of knowledges, because we need only to know the Cauchy integral theorem. Okay, but technically it's not so easy because we need to observe to know this first part, that it is sufficient to prove the above result for only for polynomial which take real values whenever the argument is real. Yes, because of this I suppose that the proof is not the easiest. The second proof of fundamental theorem of algebra, I suppose it's the most elegant proof. And this elegant proof is based on Luvia Theorem. What means Luvia Theorem? Luvia Theorem is, I'm going directly to Luvia Theorem. It's Luvia Theorem is here. Every bounded entire function is constant. Every bounded entire function is constant. Stop share, and I will write this. What means that f is entire function? That means if and only if, by definition, the fact that it's entire means that f is a holomorphic function on the whole complex plane. That means on the whole complex plane. That means a function that the function is entire. It's holomorphic on the whole complex plane. What means that f is bounded? F is bounded by definition if maps the C in this case, or F maps G subset of C in a bounded set. What means this? Writing by formula, that means there exists a positive m such that module of f of z it's less than m for all z in G, let's say, all z in G, because function is defined in G. That means I will clear this. That means there exists a disk such that the range f of G lies in this disk. The range f of G is in this disk with, let's say, with center in origin and a radius m. Yes, that means a bounded function. Luvia Theorem said that Luvia Theorem said that if f is entire function and f is bounded, then f is constant. It's constant on C, of course, on C. This is a very strange thing. Maybe undergraduate students start to contradict me. This is true. Yes, in complex it's true. In real case, in real case, it's not true. Because, for example, f of x equal sine of x, for example, it's holomorphic on R, that it's differentiable on the whole real axis, and it's bounded by -1 and 1, and it's not constant. Or another example, f of x equal 1 over 1 plus x squared in R, of course, x in R. It's bounded by 0 and 1, it's differentiable, has nth order derivative for when n it's an arbitrary natural number. It's indefinitively derivable, this function, but it's not a constant. Okay, clear. I'm going to share the screen now. So this is the Luvia theorem. Every bounded entire function is constant. How to prove this? Very simple. I'm going back. We know Cauchy inequalities. If in the closed disk with center in Z0 and the radius R, modulo of F has an upper bound M, where F is holomorphic in the all open set G. But in this compact subset of G, of course, modulo of F it's continuous, so has it's upper bounded in every topological space. Okay, so suppose that M is an upper bound for this. Then for every n natural number, n's order derivative in the center will be upper bounded by this n factorial m over r to the n. I will send this beamer to Dr. Kavita, and the proof is very simple. Is in my book. I will show this book. It's very simple, the proof, and I don't want to discuss this. It's very simple. Use the Cauchy formulas. Okay, how to prove Luvia theorem? We will use this Cauchy inequalities, this, for n equal 1. F prime Z0 less equal with 1 factorial is 1 m over r. Let's see here. Yeah. M over r. What's happened? When r tends to infinity, this f prime, this f prime Z0 will be 0. Z0 is for all Z0 in C. If a function is holomorphic in C, so this such kind of disk with center Z0 and the radius R are included in C. It's not important how much it is R. Yes, that's why it's necessary to be holomorphic in the whole C. If in a domain, C is a domain. If in the domain, what means domain? Open and connected. Okay. If in a domain the derivative is 0, then f is constant. We know this. Okay, so Luvia theorem, it's very simple. The proof of fundamental theorem of algebra using Luvia theorem is also very simple. It's also very simple. Suppose that the conclusion of fundamental theorem of algebra is not true. So suppose that P has no zeros. Then 1 over P, it's an entire function. It's holomorphic on C because P is holomorphic and P doesn't vanish. How much is the limit of Fz when Z tends to infinity? The degree of P is at least 1. So the limit of P is infinity, 1 over infinity is 0. Okay, what means that? That means the value of modulo of F could be as small it's possible when Z is as big it's possible. So let's take that epsilon equal 1. So modulo of Z will be less than, let's say, 1 if modulo of Z is enough big, greater than R. So what's happened? Outside this circle, modulo of Z equal 1, with R, outside of this circle, module of Z equal with R, outside, the module is less equal with than 1. Inside, when module of Z less equal with R, here, U bar 0 R, this is a compact set, then a module of F, it's a continuous function, has a supremum. It's bounded in a compact set. So what could we say? Outside of the circle, module of Z equal R, it's less equal than 1. Inside, it's less equal than M. So in the whole complex plane, module of Fz, it's less equal with, let's say, M plus 1. Outside, it's less than 1. We add an M positive, okay? Inside, it's less than M. We add 1. Okay, so this F of Z, it's an entire function. An entire function, as I said, and upper and bounded. So what's happened according to Luvia Theorem? It's a constant function. F it's constant. It's a C. F of Z equals C. So 1 over P equals C. So P equal 1 over C for all Z complex number. That means the degree of P is 0, but we suppose that the degree of P it's at least 1. Yes. So we get a contradiction. On my opinion, this is the much elegant proof of fundamental theorem of algebra. Okay. The third proof of fundamental theorem of algebra. It's also very simple and elegant, but it's necessary to know the so-called Ruchet Theorem. Ruchet Theorem, it's based on the variation on the theorem 1.4. That means the variation principle of the argument. I will not discuss this variation principle of the argument, but I will discuss Ruchet Theorem. There exists a proof of Ruchet Theorem, but this proof, let's look here, Theorem 1.4, it's based on it's based on the variation principle of the argument. Yes, maybe for students it's a little bit difficult to understand the proof of the variational principle or of the argument. The second step, that this integral is an integer, it's not easy. It's not easy. But let's discuss about Ruchet theorem, which I like very much. Suppose that suppose that F and G are holomorphic function in an open set, and gamma is a boundary curve. That what means boundary curve? Is a simple curve without double point. Just immediately I will draw this, such that there exists gamma derivative, which is continuous. Let denote by D that bounded domain which is bounded by the curve gamma, and suppose that this the closure of D is in G. Stop share, and I will make a figure. So this is the open set G, and we have a curve gamma. Gamma is a boundary curve. That means this is the path of gamma. This blue curve. What means is a boundary curve? That means gamma derivative is continuous, and has no double point. So the curve gamma doesn't look as this one. This here there are double points. Doesn't look as this one. And we denote by D the bounded domain bounded by gamma curve. That means the gamma curve split the complex plane in two regions. Maybe I will use a better color. This one. This is a bounded domain, which boundary is the curve gamma. This is the D domain. And the other domain is the exterior. This D domain should be in the same way that the closure is in gamma. Okay. Okay. So it's a very simple. What we suppose? We suppose that we have two functions, f and g, that are holomorphic on the whole G. Yes. Okay. There are holomorphic on the whole G. But if I take an arbitrary zeta on the boundary of gamma, on the boundary of D, on the boundary of D is this curve gamma. In such zeta, G of zeta, it's less than f of zeta for all such zetas, for all such zeta points. What follows now? What follows now? I wrote here. The number of zeros of f, the number of zeros of f, and the number of zeros of f plus g is the same. So if to this big, let's say, called big function, we add the smaller function, the smaller in module on the boundary, only on the boundary here, then the number of zeros of f is not changed. F and f plus g has the same number of zeros in D, not in G, in D. Stop share, and I'm going back to the theorem. Okay. Dr. Kavita, you see now the beamer, no?
Yeah, it's visible, sir.
It's good, no?
Yes, it's good.
Okay. So what I wrote here, then what we suppose, modulo of f it's greater equal than modulo of g on the boundary of D, on the gamma curve. In this case, the next two equation has the same number of zero. F of z equals 0, fz plus gz equals 0. That means the order of f in D, the order is the number of zeros minus number of poles. There are no poles because are holomorphic. The order of f in D and the order of f plus g in D is the same. But let's see, let's not complicate with this notation. Let's see this. Only this. These two functions have the same number of zeros. Okay. And now the proof. The proof is... No, sorry. That is the proof of Ruchet theorems using the variation of the argument, the principle. This is the proof of fundamental theorem of algebra. Only one page. Only one page. Let's consider the next two equations. A sub n z to the n equal 0, and the other one p of z equals 0. Who is p of z? I'm going back. P of z is this. Sorry, is this one. It's here, it's capital P, but not capital. This P of z. P of z. Let's, sorry, I'm going back. This is, this is P of z. Okay. Let denote this function a sub n z to the n with f, and a not a sub 1 z, a sub 2 z square, a sub n minus 1 z n minus 1 with g. Degree of f is n, degree of g is n minus 1. So limit of g over f when n tends to infinity is 0. Degree of f is bigger than degree of g. What means degree is 0? That means the modulo of f of g could be at least as possible when modulo of z is enough big. So there exists an r not positive such that if r is bigger than r not, then modulo f over g it's less than 1. I will write this where it's happened outside the disk with center in R naught. Stop share. I will. I've only one figure. I will clear this and I will draw only one figure. There exists a disk with center in origin and radius r naught, such that if I take an arbitrary r bigger than r naught, and if I will draw the circle with center in origin and radius r naught, this is radius r naught, this is radius r, and this red circle will be gamma. Outside of this black circle, what's happened? Outside of this black circle, that means on this red circle, module g over f, it's less than 1 if zeta is on this circle gamma. This is an elementary fact that limits of f over of g over f when argument tends to infinity, it's 0. Then the module could be as less as possible. As less as possible. I am going back to finish the proof. So this one. What means this? That means modulo of g less than modulo of f. So we need to apply only Ruchet Theorem on this circle gamma, which is the boundary of the circle with center in origin radius r, and apply. If we apply this, what we obtain? What we obtain? We obtain that the number of zeros of f of equation 1, 2, and number of zero of f plus g, which is f plus g? F plus g is p, no? G is this one till here, and we add this one, no? This is f plus g, is p. A0, A1, Z, A, n minus 1, Z minus 1 plus A, n, A sub n, Z to the n. That's its p, f plus g. Has the same number of 0 in that circle with center in 0 and radius r. But how much 0 has f in that circle? F has n0. It's only one, but the multiplicity is n. Z not equal 0. It's an nth order 0 for function f, because we count the multiplicities. Yes, but what I wrote, but the equation 1, 2, this has exactly n zeros in 0. Okay, and the proof is finished. Okay, I am not discussing about isolated points, but almost all of these results are in this book, which appear in 2019. To finish my book, I collaborated with my friend Santosh Joshi from Sangli, and Pranay Goswami from Delhi. He works in Rajasthan, and the topic of this book I was teaching about 35 years to my university. At the first look, Santosh and Pranay said, "Oh, but it's there are quite difficult things in this book because also the theory is not easy, and applications are enough tough." But in my country, because Romania was a former communist country, we use that Soviet type of mathematics, which is a very good one, Russian, Soviet, Russian, Ukrainian, okay, let's say Soviet type of mathematics. And in this book is not as Conway's book, where there are no proofs. All the details are proven here. There are not any things which is not proved exactly and very sharply. Unfortunately, for our students, it's enough expensive. It's about 70 euros, this book, but okay, in our faculty bought this book. I don't know, about 10 books they bought, because institutional access, it's about 900 euros or something like this. Yes, all it's contained here, even these proofs. Yes. So if there are some questions, or please ask me now. Thank you very much for your attention.
Thank you so much for your admirable session, sir. Now it's time for discussion. Kindly post your questions in chat box. If you have any queries, you can post your questions.
For details, I will send after this discussion. After we will finish, I will send to Dr. Kavita this beamer, and who need to have it, please ask Dr. Kavita.
Okay, sure.
Definitely, sir. I'll share it with everyone.
Thank you.
Maybe the girls could feel shy about asking some questions over here, sir. If there are any questions raised by the students over here or in the YouTube session, I'll pass it on to you, sir, through the mail.
Yeah, yes. Yes, our students are not so shiny. Our students ask every time they put questions, and also online. All the time they stop me. Please explain this again. Please explain
Yeah,
this.
yeah,
Yes.
that happens with their yeah, that's sure, that happens with their faculty members. Maybe here I think I'll pass it on to you, sir, if the questions, if any questions has been raised by the participants, any of the participants.
Okay, now I would like to invite Ms. Meera from First MSc Applicable Math to express a gratitude. Welcome you, Meera.
Good afternoon, everyone. First, I thank God Almighty for His presence. I'm here to present the vote of thanks for today's international webinar on the fundamental theorem of algebra, 3 proofs using complex and lattice method. I would like to thank our speaker, Dr. Theodore Bulboka, PhD, DSc, Faculty of Mathematics and Computer Science, Babes Bulga University, Romania, for enlightening us with their knowledge. Today's webinar was full of knowledge and interesting things. It gave deep insights into the topic and also revealed interesting facts. The points you told us was really informative. I'm sure the precious knowledge that you gave us will definitely help us in our studies and future. I would like to thank our management, principal, vice principal for their guidance. I thank all the participants for their harmony. And I also thank the faculty members and students for their huge support. Thank you.
Thank you. Thank you very much for the nice words. And please, Dr. Sudha.
Thank you, sir. Thank you so much. Thank you so much, sir, for the wonderful session. Once again.
Thank you. I would like to say a few words at the end. As I told before my lecture, I was many times in India, starting from the south. First time I was in Chennai, that was in south, but I was in other places. And the last time I was in Roorkee, in the north of India, in Roorkee and in Delhi and in Bhubaneswar in Odisha. And I saw many places in India. I hope that this illness, this coronavirus illness will finish as soon as possible. And if I will have the opportunity to visit again India, I will be happy to go again in Chennai, where I was a few times, to Indian Institute of Science, IIS Chennai, and to long time ago to Ramanujan Institute in Chennai. Yes.
Yes, sir. Yes, sir.
Yes, I will be very glad if I will have the opportunity to go there to visit your college and to have
It's our pleasure,
a live lecture with your students, but only in the topic of
We welcome you, sir.
complex
Please.
analysis.
It's our pleasure, sir. Thank you so much, sir. So down to earth and kind-hearted.
Thank you, sir. Thank you so much. It's our pleasure, sir.
Thank you.
Thank you so much, sir. We are honored to have you, sir. Thank you. Thank you so much.
Thank you. Thank you. Thank
Definitely,
you.
our students would be benefited by this talk. I think I'll share all these materials with them, sir. And as the next part, if they have their questions, I'll move it on to you, sir. And after all this pandemic is over, we are looking forward to you to our college directly when you have your India visit, sir.
Yes. Thank you, Dr. Kavita. Thank you,
It's our
Dr.
pleasure, sir.
Ambarasi. And I will send just now the beamer file of my presentation to Dr. Kavita.
Yes, okay,
Thank
sir.
you, sir.
Okay, sir. Thank you, sir. Thank you, sir.
Goodbye, goodbye,
Thank you, sir.
Thank you, sir. Goodbye, sir.
goodbye.
sir.
Okay, ma'am, shall we announce break, ma'am?
Yes, yes, Anna. Yes, Pratibha.
A sweet ending to a new beginning. Let's have a break, and we are having our next session, Recent Trends in Career Opportunities, will commence at 2:30 p.m. Thank you so much for your active participation. Let's meet again after a break at 2:30 p.m. Thank you all.